Hey, everybody, welcome back to your Dawn of Autonomy podcast. I'm Dawn Zoldi, your host, CEO of P3 Tech Consulting, and publisher at Autonomy Global. We are rounding out an amazing month that we dedicated to the theme of defense tech. And honestly, we couldn't end this month without talking to Mario Paniccia from ANELLO Photonics. Mario's been a wonderful friend to the show. He's been on a couple of times. So much going on in this space, and this is absolutely where ANELLO fits. So, Mario, welcome back to the show.
Great to be back. Thanks for having me.
Absolutely. So, Mario, I know you've been on the show before, but we always have a lot of new listeners and viewers. Can you tell them just a little bit just about yourself first?
Yeah, sure. So my name is Mario Paniccia, live out here in the Bay Area or Silicon Valley, as some people call it. I spent 22 years at Intel, was an Intel fellow, which at that time was the highest technical level. I helped create this field of silicon photonics, which is building optical devices out of silicon. And that's used for high-speed connectivity today in all the data centers, AI. So 70–80% of the data center today, all the connectivity is based on silicon photonics. I left, took a startup that I ran from Corning, and then we started ANELLO in about 2020 with the goal to build or siliconize the optical gyro industry by bringing integrated photonics to gyros and take these big, bulky, expensive things that are in all fighter jets, submarines, shrink it down to a integrated circuit and bring it to the autonomous world, which, as you see today, the autonomous world, not just in the industrial market, but in the defense market, is quite the new direction that we're doing across land, air, and sea.
Absolutely. So, a lot going on to unpack there, especially for people that have no idea what silicon photonics are. You kind of mentioned some things that are in fighter jets, the gyroscopes. So let's kind of unpack it just a little bit, and let's keep
Okay.
it somewhat high level. And what I
Sure.
would remind everybody is, if you want to go deep into these things, first of all, check out, of course, ANELLO's website. But secondly, check out our previous Dawn of Autonomies with Mario on there, especially our very first one. What was it, like 3 years ago, Mario?
I think so. We've done a couple of these now. Yeah.
Because I was definitely in learning mode, like, all right, tell me what this means. But, for those that don't know what, silicon photonics are and why a gyroscope, putting, them into a gyro, or like the connection between gyroscopes, and what does it mean? What does it all mean for autonomy?
Sure. Let's start off with silicon photonics. So today, when you think about photonics, photonics is about transmitting or using light instead of electrons. So instead of copper cables, you use fiber. Instead of electrons, you use lasers. And so silicon photonics is the field of creating optical devices using the standard same processing that electronics are being done with. So all the billions of chips today, or multi-billions, are based on integrated circuits, wafer processing, Moore's law. And because of the vast volume of that, it's cost economics, which is why 10 years ago it was a supercomputer, then it was a server, then now it's a laptop, and now what you can find in a phone is the same performance, or in a watch that 5 years ago was in a laptop. And that's all based on integrated electronics, where you're integrating and processing transistors fast. As you make the transistors smaller, you get more transistors per unit area. As those transistors get smaller, the yield goes up because there's not a lot. Dust particle can't affect a lot of things. And as they go smaller, they go lower power and they go faster. So you get the same computational power in more functions in a smaller device. So that's integrated photonics.
Okay.
Silicon photonics is now taking the same processing and the tools that you make electronics, but I make optical devices in silicon, and I send light into the side of the silicon so I can route it, manipulate it, detect it, transmit it from two pieces of silicon. And
Okay.
that's silicon photonics. And integrated silicon photonics is when you put lots of devices together, lasers, modulators, detectors, and integrate those. So now you have a transmit and receive function.
Okay. And the gyroscope piece of it. How does that all
Okay,
fit?
so now if you look at a gyroscope today, this is a 3D print of sort of a standard fiber optic gyro.
Okay.
Today they're made out of big bulky components, lithium niobate, APDs, lasers. They're discrete components. It was where the optical industry was 20, 30 years ago.
Okay.
Fiber optic gyros have been around for 20, 30 years. They are the cornerstone. Why are they so beneficial? Because with photons, they don't interact. So it's not sensitive to temperature, not sensitive to vibration, not sensitive to EMI, electromagnetic interference. So it's phenomenal for being independent of things. The drawback is it's big, bulky, and expensive, right? This is a big, I call it a coffee can size thing. As we move to the tradable world, you want small, you want high volume, you want scalable technology.
Right.
So that's the concept of a fiber gyro. How do gyros work in terms of why is that important for navigation, and how do we get GPS denied navigation, which is the focus of all this?
Right.
So there's two types of gyros for the user. So there's a gyro that's in your phone,
Okay.
in your watch, in your earpod, and that's a MEMS-based micro electronic machined material. It's a piece of silicon that's vibrating,
Okay.
and it's a sort of it resonates. And as that resonance changes, as the gyro measures rotation or drift. So if you're pilots, people understand you're sitting there, you measure drift or rotation. And as you're navigating, you want to know what that error is as you're drifting. What's in your phone is okay for course alignment, but it's not very accurate. The drift is too high. Fiber optic gyros, if you go to really accurate ones, in submarines, they're half the size of your desk. So they're very accurate. They have very low drift. And as you're navigating, if you use the drift of the gyro to contain on your algorithms, it'll help you navigate because you use the gyro. It's not depending on anything else. It's dependent on self to use to minimize or contain your navigation path.
Okay. So you just mentioned electronic warfare, GPS denial, maybe spoofing, maybe jamming. I mean, we're seeing this on battlefields globally, but we're seeing this also commercially as well, right? I'm reading things like just commercial airline pilots are getting spoofed routinely, and not even necessarily near those zones that we're talking about, those battlefields, which is frightening. So, this is critically important, obviously, for all transportation, but definitely for autonomous systems and specifically in defense. So tell us about that nexus.
I think if you step back, the entire world has been based on GPS, which, the satellites, so you can actually, you get your data points as you're moving, the GPS tells you where you're at, and it's been very good. What's happened over the last couple of years, and it started off, as you said, in the defense or military actions, Ukraine, Israel, jamming and spoofing is happening. So jamming is, you basically throw a bunch of RF out there and you jam the signals. So in the military side, it's jamming. They're big jammers either from the sky or from the ground, and they distort the GPS signal so you lose it. Jamming in industrial cases is tunnels, bridges, downtown, urban canyons where the GPS bounces around or you can't get it. And that's why jamming I call both industrial and defense.
Okay.
Spoofing is different. Spoofing is, and jamming is somewhat easy to detect. You basically lose the signals or you lose the number of satellites. Your receivers can detect that. Spoofing is different. Spoofing is someone hacks the satellite, right, and basically moves your position, but you still get, if you're on a receiver that's receiving the GPS signals, you can't tell if it's real or not. So you get spoofed, and what they do is they move you. And so you think you're somewhere else and they move you, and that's called spoofing. And why is that important is that over today now, everyone's realized that jamming and spoofing can happen quite easily. In all these military, we're finding out, not just in Ukraine where we first started to see this, and then in Israel, and now in Epic Fury, jamming and spoofing is everywhere. So everything that was relied on GPS doesn't work anymore. Right? If you want to get your position, if you want to, whether it's a missile, whether it's a helicopter, whether it's a tank, that's even the soldiers. But the second piece is happening is it's also affecting commercial. So in one case, like if you're, I'll use the Israel example. If you're in Israel and they're doing spoofing, if you land and you use your phone for navigation, it'll send you to Beirut, or it'll send you to Gaza, or you don't know the difference because your phone's just picking up what's out there, right?
Wow.
Secondly is, as you mentioned, And now a lot of commercial airlines are being spoofed,
Yeah.
and so it's starting to, be that people who've relied on GPS, um, unfortunately, it's very easy to jam things. You can buy a simple jammer. All these cars that are dependent. You see these movies and stuff where you see this, but I think it's a real. And I was just on Capitol Hill yesterday again, talking to various people of Senate Armed Service Committee and House Armed Service Committee, and I think this realization that you don't have to. All you mentioned is GPS denied, and everyone starts writing very fast, right? And what can we do? How does it work?
Well, I'll tell you, Mario, like
right?
I'm laughing because, this is another like problem that some people have been shouting from the mountaintop about for years and nobody pays attention, right? Like, I mean, the Department of Transportation has been yammering about this, the US Department of Transportation, for years, right? They did studies on this. They're looking for alternate or complementary PNT solutions, right? I mean, this has been ongoing for years and years. So for some in government, it's not a surprise. For others, they're like, wait, what? What is happening? So it's good. It's good that you're catching them up, Mario, and we're catching everybody up right now if they didn't know. But really big problem. So how does your technology like address that problem?
So to your first point, I think, look, sometimes you just have to keep educating people,
Absolutely.
and
A lot of turnover.
it's also when it becomes their problem, it becomes more of interest. Right now, this is our problem because we're in places where we need GPS and our GPS technology doesn't work, and so.
Yep.
And then sometimes in life, it just takes time for people to realize things, and so that's part of my job and what we're trying to do. Part of this conversation is to educate people. So GPS denied, I think people and the government and defense, and also it's going to bleed into commercial areas, are starting to realize that we need to have GPS denied capability, and how do we navigate with and without GPS, whether it's
Right.
emergency responders, any of those kind of things, that if the GPS goes away, what do we do?
Right.
So the second thing is, how does ANELLO do this? So first thing we've done is we've taken the concept of a fiber gyro, big, bulky, but gold standard, works very well, and we've shrunk it. So this is our SciFog, silicon photonics optical gyro. It's the world's smallest optical gyro.
Is it a little bit larger than a poach's
It's a little bigger than a
stamp?
postage stamp. I say it fits in the palm of your hand. It's a little bigger than a quarter, for those who know what a quarter is, but it's about an inch on the side. And you can see it here. It's very small.
Yep.
And inside here, which we don't show a lot, but there's inside here, if you look at the guts, it's a bunch of electronics. I'm going to put there's a little photonic chip at the top there. That chip is literally 2 millimeters by 5. There's a little laser at the top there.
Wow.
And you can see my finger, right? My fingernail. It's just quite small.
It's actually way thinner than your nail.
And so we've taken all these optical devices that are in this, shrunk it, and put these new devices into a piece of silicon, processed it just like semiconductors. And now if you notice on that picture, the light goes through the side of the chip. But that integration of that little chip has about 34 components in there. And the next generation will put more and more. And so now I've taken, but it still gives you the same precision of a fiber gyro and all the benefits of a fiber gyro. So now I have this small, high precision, high volume manufacturable device. I mean, we've designed this for millions of units. The autonomous world, especially if you look across unmanned surface vessels, unmanned underwater vessels, drones, no one's had 1 million units of anything yet, right? So we designed this for scale.
Yep.
And now we can put this in places because of the size, weight, area, and power into attritable things, into drones, into small, that's the big difference, right? And so we've taken this concept, integrated, shrunk it, and now I can bring it to new markets and applications, that swarming of things, autonomous things, right? That's what we've done.
That's amazing. You're talking about attritable. I know, look, we were just at Exponential, right? Soft Week, all of these things, Mario. Like, obviously there's a big, flood of money coming in, I think, from the DoD, and these issues are obviously of interest. This idea of attritable drones or attritable autonomous vehicles, not having to send humans into the fray, if you will. If you lose them, whatever, they're not exquisite multi-billion-dollar, program of record systems. All good. I guess my question is, because we've seen, I'm going off script here, so bear with me.
That's fire.
I'm just curious because what you just showed me is super intricate, right? And obviously it's your IP. So like this isn't an attritable drone, you know, they send it downrange, thing gets blown out of the sky, say it doesn't quite blow up, and this thing's on the ground and someone can pick it up. Can they reverse engineer that? Or like are you working with the companies that will integrate this awesome technology into these types of attritable systems, that there's some kind of a kill switch or something that, you know, like they have in the Air Force on those big jets. Like if needed, you can push that button and the thing's gone, right? Because you don't want the enemy to get your awesome tech.
Yeah. So first of all, if we did or don't, I'm not going to tell you.
Okay.
Um,
If you
just to
told me,
be
you'd have to
clear.
kill me, so I
Yeah, I
understand.
don't know if I, yeah, I think, but I think a lot of it's very difficult to reverse engineer this chip because there's a lot of subtleties. It took us 4 years to build this. It's very complicated. I mean, it's
Wow.
nice to
Yeah.
show the picture,
Yeah.
but we do things. We do take care of those things. This first generation technology is non-ITAR, and that allows us to do the dual use, right? Because we are shipping both into industrial and defense. In the
Roger.
future generations, more of that stuff will become important as we go into ITAR related higher performance systems that will just allocate for special customers. And so
Got
those
it.
kind of things will become more and more important.
Okay.
But let's just say those discussions have happened
Yeah.
and we'll leave it at that.
Yeah. Well, you know, former Air Force here, so that's where my brain
Yeah.
goes. But so you over time, you said it took you 4 years to build this chip. You keep making it better and better over time, and I know in different form factors, which we'll get to here in a second. But I want to talk about your team for a second. And we have a cool picture. I visited your booth at CES this year. I've seen you
Mhm.
at this show a couple of times. I know it's a great show for you guys. It's international. People from all over the world stop by to check out what you're doing. Here we are back in January. Your team, tell us a little bit about your team and, you know, how's it grown over time? Because you're now talking millions of units that you're able to crank out. How's that looking?
So first of all, great to see you. I was wondering if it was cold in Vegas because you're wearing a hat, but
I look, I had to get the logo going,
oh,
right?
that's what it
Like
was.
people like see me and they need to see it beaming off my head.
I see. So yeah, the we just closed I think it was announced last week, a 25 million funding round, and that funding round specifically for growth. So when you look at the team, we had this core team. We're mostly located here in Silicon Valley, and this is complicated technology. So
Yeah.
the current team, I have a seasoned staff, right? That we've all shipped. My COO in his heyday shipped 1 million units a week. Think about
Wow.
that, of
Wow.
photonic devices, right? 1 million units a week, just to put the readers and the listeners into context. The technology I developed at Intel, I think to date has shipped over 50 million
Wow.
units, right? So when I say high volume, we've created. So I have a senior staff who's very experienced. We have a lot of PhDs. I think we're up at 14 PhDs in the
Yeah.
company, just
Mm-hmm.
because the technical level of the complexity of what we're building, not just at the photonics level, to the electronics level. But
Yeah.
this next round of funding is now that we have this technology and we have various products. We have products that address land, air, and sea. Is now about scaling. And so this funding round of 25 million that was just announced, we also have an APFIT award that we just won, was publicly announced, I think in January. That was $20 million with the Marines. That's for dedicated capacity. And APFIT is a pre-production activity that the Pentagon puts in place for key customers. It's all about scaling now. So the hiring we're doing today is manufacturing engineers, product engineers, supply chain people, those kind of hires, and then manufacturing people as we bring up the production lines. And we've designed this technology so that we can scale. So we have we designed this in terms of a Lego box. We can have, here's our manufacturing line with certain pieces of equipment on the front end to build the SiPhog. And then on the
Yep.
back end, I call it the back end when the products are built, we do testing and calibration. And these are ovens and rate tables, and those just need to be, scaling. So we've designed this so that a fixed amount of capital gets us a fixed amount of volume, and then we can just add to that as the business grows. And so this is the next phase of ANELLO is taking these existing products for land, air, and sea and scaling those. And what we've designed in the first generation is this is the core tech. We have the SiPhog, And then, for example, for drones, we put 3 SciFogs in a cube. And this is, an IMU. If people want to do their own algorithms, we have INSs. This is what we announced at CES. This is the aerial platform. It has dual GPS, L1, L2, L5, integrated CPU, algorithm here. So this has the full system. Yep. We have a similar one for maritime that's watertight IP68. And then we have a land vehicle version that's a single axis that we're shipping into industrial, farming, construction, all based on this. So we build this in volume, and then we put those into systems.
Well, first of all, congratulations on the AFIT award. That is a really big deal, but that's not the only award. You've actually also been recognized by the Naval Technology for their 2025 Excellence Awards towards the end of last year. So I think we've got a little image on that. Pop that up. And congratulations. The team's growing, the recognition is growing, as you said. Back when I first met you, we were just talking about the actual original product, and now, as you said, land, air, sea, scaling across the board, winning awards. Love it. This is amazing. So let's let
me just might say, like, I'm honored to lead this team, right? These awards are not me, right? It's I get the benefit, but the key to success is hiring people smarter than you, brighter than you, and I found you put a bunch of bright people together, and you challenge them, and you keep challenging them, and you come up with these wonderful things. And it's a great recognition when you get these awards, because it's not from us, right? There are other people outside who are testing our technology or using our technology, and that leads to these accolades. But the accolades to me means that you've built something that people want, that people like, and more importantly, it actually does something useful that people are willing to pay for.
Exactly. So let's kind of break it down. You cycled through them pretty quickly, but I want to dwell just a little bit. Let's start with air. So show us your box with the triple SciFog in there.
So this is, go ahead. Sorry.
No, I was going to say, like, explain, again, in the context of autonomous systems, right? We're seeing more and more, Mario, we're seeing in the public safety side, drone in a box systems, right? We're seeing precision agriculture. You mentioned some of the land-based vehicles, which we'll get to in a minute, and they're big too, autonomous tractors and things like this in precision ag. But we're hopefully get a beyond visual line of sight rule, right? So now people aren't even going to be able to see where their drone is going and what it's doing with their own eyeballs, which makes this even more important on the commercial side, whether it's drone delivery, drone as first responder, you name the use case. So tell me then how your UAV type unit here that you were just showing us, the airborne unit, how that helps with all of that.
Okay, so first thing is, this is, just to put it in context, this is the equivalent performance of this. So the LN200 today roughly is, $50,000, $60,000, depending on the features. This is the X3, we call it, 3 SciFogs, a fifth the size, quarter of the weight, quarter of the power, and obviously price-wise, much different. Inside here, this is a mechanical, so there's 3 SciFogs. But what I don't mention is every one of the SciFogs has gyros in them, accelerometers in there. We have magnetometers in here. We have barometers, temperature sensors, about 34 sensors in there.
Wow.
So how does this work? First of all, if you're flying and you lose GPS, we have, if you're using the IMU or INS, we have a system that detects, hey, you're being jammed or being spoofed.
Right.
If you are, port over to ANELLO. So drones today, and we've learned this in Ukraine, if they're flying on a clear sky, fantastic. The minute they lose GPS, drones don't know what to do. They don't know where they're at anymore. You can't return to home. They sit there, they hover, and they crash. And with ANELLO on board, we can say, hey, don't worry, port over to ANELLO and now navigate with ANELLO, use the low drift. Depending on the air, it will determine. That's why you need 3 axes, right? Because the heading is key. And if you're just doing a straight line, you only need 1 axis. But because you're moving, you need 3. The second thing is, when you lose GPS, you have wind or currents in the water. You have to factor those out. And so we take in pitot tube or wind velocity, put that into the algorithms, and we calibrate that. So now we're able to do, think about this, with something like this, whether this is the IMU and people put their own GPS and use an Ardu pilot or Cube, or we have the full INS, which a lot of customers start here. And then they say, hey, we'll just take the box and we'll plug it in. It saves us all the effort. These have been optimized for algorithms for air or algorithms for water. Think about this. We're now navigating, no GPS, with error of distance traveled between 1% and 2%, or 98.5 on average, accuracy over hundreds of miles. Right? No GPS, no cameras, no nothing, just ANELLO. And so we've solved the problem. You got to get through that jam region to get to the other side, to where you want to go, where you turn on the camera if you're doing ISR, if you're doing a kinetic, to get close enough where you can put a seeker or something on. But we're solving that problem. We're not trying to solve the 20-hour problem. We're trying to solve through these. But and a lot of these missions, like in the USVs, think about this. You're in the water, or even on drones. Cameras are great, but they don't work over water.
Well, they don't
work over
underwater.
Clouds.
So does your box work underwater too?
Yes. So we do. Yes, we do USVs, unmanned surface vessels. We also do unmanned underwater vessels. And publicly, we've announced a partnership and a design win with Vadin. They're out of Rhode Island. They do UUVs. And these are the benefit of the maritime boxes, I call them. They're IP68. They're salt spray sealed units, and the aerial ones are designed for weight, so they're lightweight. We've trimmed off everything that's not needed. But obviously, for the maritime, salt, water, oceans, you have to take that into account. So that's the way our systems work, right? So if you have GPS, you use it. We detect it. If you're losing GPS, we port over. And the other thing we do is every 10 milliseconds in our systems, because we believe our position. Right, because of the accuracy. It's not that fiber gyros are new. It's just that we created a fiber gyro performance in a small form factor. We compare our position to GPS, our position to GPS. The minute they diverge, we say something's wrong. You're being spoofed. And so then we pour it over. So this is the algorithm piece that's tied into this small box, right? And this is the key. These things. Look at these things. I mean, when you look at every time we show it to somebody, they're like, "That's the box." That's the performance you get.
I mean, I'm just looking in the perspective of your own hand, like your palm.
Yeah, I mean, it's look at it. I mean, just to put it into context, this is your iPhone, right? Smaller than iPhone.
Wow,
right?
that's unbelievable. And what you mentioned, 34 sensors, and you're talking algorithms. So AI is the coin of the realm lately, Mario. Of course, interestingly, I didn't see a ton of AI companies running around, like at the booths at Exponential. I imagine, at Soft Week last year, I know Caresoft brought like almost 60 AI companies with them alone. That was 2025. But what role does AI play, like in this whole, form factor, like in the whole system you've got going on here?
Yeah, I think, AI is different for different people. I mean, we have AI in our system that does this calculations and comparison, and we look at different things. We have about 14 things we look at. To your point, in Exponential, I didn't see a lot there either. At CES, it was all about AI, right? If you look back a couple
that
months,
was crazy.
Right?
I talked about that.
And Exponential, I think, was more about the systems and the drones and the components to make drones, and there was a lot more. Some USVs in there, more unmanned ground vehicles. But I think as we go forward, you have to take into account and what we do is the user doesn't see it, right? The box spits out real-time position. It handles all this automatically. We constantly update. So as the system flies, and we like every time we integrate with a new partner, what we've done, and this is what's been very successful for us. So we have we met a couple of new customers at Exponential, for example, right? And one of those is doing ship-to-ship refueling or ship-to-ship cargo. And I just say, look, let's just test. I'll fly someone out. We'll install ANELLO onto your platform. Let's fly it. We collect the data. I ship the data back here to our headquarters. I have my algorithm team look at the data, tweak the algorithms, send it back. They fly again the next day. In 2 or 3 days, we're up and running.
Wow.
And what happens is every platform is different, right? Depending on where you put it, how you bank and how you turn. And what I find, I call it the white glove approach, where we really work with our customers and I fly people out. This is part of the other hiring is, I call them field application engineers, but these are a lot of times I send my PhDs out because I want to
Yeah.
make sure it works. I want to make sure that we get the best people. And once it's running, then the customers are always amazed at the performance. And
Yeah.
then that's how we get designed in. So that's the algorithm piece, right?
Yeah.
You can call it ANELLO AI, you can call it ANELLO algorithms or AI, but it's sort of, it's the new world. I mean, and I tell my team all the time, are we using AI properly? Or do we need to get better tools when we do the software, when we do the algorithms, when we do the manufacturing? We're looking at all this data and statistics.
Yeah.
Are we using AI to analyze it so
Right.
that we can improve yield, so we can improve? And so I think, there's a difference of what's termed AI, but I think if you're not using it today, it's not just for searches, right? It's not ChatGPT to do a search. It's
Yeah.
actually
LLMs.
using it to
Yeah.
write the
Sure.
code and all this,
Yeah.
right?
Yeah. Well, that's actually, I just learned something new. I didn't realize, I thought you just bought the box, right? But like, you're like basically customizing the algorithm to accommodate the vehicle and its flight characteristics, or swimming characteristics, or ground, driving characteristics. That's quite amazing that you're doing this white glove um, concept. So it's no wonder the money is flowing, Mario. I mean, when I first met you, I knew this was going to happen. You've expanded now all these different products. You just talked about the AppFit award, and I think we've got a little like thing to put up about that. That was 20 million. That was in January. Very
Mhm.
awesome. And you also, I think, just closed a 25 million Series B round recently.
Yes.
So besides the hiring and all what else what does this money mean for you? What does it mean for ANELLO going forward?
Well, I think the one is it says a testament to, like, the AppFit Award is a testament that was from the DOW,
Yeah.
that for pre-production, they're paying for a dedicated production line. We are designed into some key platforms and drone platforms onto
Mm-hmm.
that, for that's not public. But that's, I think, a statement that we've spent a lot of time testing on these platforms. We're designed in, and we are the recommended navigation solution for some drone platforms and future ones that are coming, right? So now we by default are being requested, whether it's GFE or highly recommended, that you use ANELLO for your navigation.
Yeah.
And so that's the testament. And AppFit helps because it's money that helps build this pre-production,
Mm-hmm.
that allows us to scale. The
Right.
investment is just a second statement of, these are VCs and investors coming in who've looked at our technology, look at our customer, go dig into our data room and look at our contracts that are coming, talk to our customers,
Yep.
and now we're investing because of what they see as the capability for ANELLO, what our future could hold, right? It's an investment in the future.
Yep.
But I do believe, I've said this before, but I've worked at Intel 22 years. So, Intel had this Intel Inside campaign where we were the core
Yep.
computer, not, the brain for every computer, right? The core
Sure.
CPU and the Intel Inside for all the PCs in the industry, right? I believe in ANELLO. The mission was that we will be the core navigation solution for anything that moves. And I believe even more now that we're on that path very aggressively. And it's not just autonomous, it's land,
Mm-hmm.
air, sea, above and below. The next thing is man portable, right? We're going to integrate, we're going to make these things smaller. You can put them on soldiers, you can put them on handhelds, you can put them. And then
Yeah.
the next frontier, or the last frontier, maybe, is space, right? There's a
Well,
lot of interest now in space.
yeah.
I see the buzz. People are coming to us, and you're putting all this stuff up in space. They need to know where they're at. They need the rotations. And so, same thing in space. Size, weight, area, power matter, right? You don't have unlimited
Well,
weight
especially
to
because
put
some
up
of the
there.
satellites are like the size of Rubik's cubes, right? Or smaller. So like those small there's microsats now. I mean, it's crazy. But one thing you didn't mention, which I'm sure also is relevant, Mario, because we were both at CES. I mean, you couldn't walk 5 steps without running into a robot.
Uh, I call that the man portable robots. Yeah, maybe that.
Okay, all right. I was
Yeah,
thinking more
I like. Yeah,
tracker type
right.
stuff,
But
but
I think
or like the
you're fair.
exoskeletons, but like, when I think of the humanoids, that are coming down the pike, all the different kinds of robots that are navigating our world, and will be even more so. I'm going to Tokyo here soon. So I expect to see a lot of robots out there in Japan. Really excited about that. But man, all the different uses for this. And so the portfolio is expanded. The financial portfolio itself also is following, as are, of course, the partnerships. So you mentioned Vadin, which is a maritime collaboration. You also announced Delta Black Aerospace.
Yes.
Tell us a little bit about that one.
So two things. One is I will add to my pitch now, land, air, sea, robots, and man portable, because you're right. I mean, humanoids
You
and
got to
robots
have
are
robots.
different. Yeah,
Robots
and
are
I think it's
cool.
sort of, as we shrink down and, the next generation of this will be smaller. And, that's where size matters. But as you shrink and you integrate, you also can scale in volume and the price goes down. And so
Exactly.
those high volume markets are sensitive. So in terms
Yeah.
of other press announcements, we announced a couple of weeks ago at Sierra Space with a Black Sea. This is the GARC, where we designed into their Chaser platform. This is a USV platform that's funded in a program with the Navy. We announced a partnership with Delta Black, and that is, I call it, I mean, it's the right word, but it's a dump truck for VTOLs. It's a big VTOL that's
Oh,
carrying heavy lift.
okay.
Um,
Very large cargo
and
drone. Gotcha.
yeah, it's a cargo drone. But what's happening, and I believe this whole cargo ship to ship, land to ship refueling or stuff, for lack of better words, is another new thing that's growing. Because what happens is, and I was talking to someone about the economics. Let's say you want to bring something out to a ship out at sea, and
Yeah.
even if it's a small like component, a replacement part,
Oh, yeah.
or just some medicine or medical aid.
Yeah.
You typically today have to fly, you're in the Air Force, you have to fly a helicopter out there. You have to
Yep.
put two pilots on there, and then usually have someone in the back with the container that's sometimes carrying a small box of stuff. The
Yeah.
cost to do that and the fuel is very expensive.
Well,
So
same if you
this,
have to actually you have to use a little boat to get out there. You're just, for the most part, depending on how far you're talking, I mean, you're burning a lot of gas. There's people on board, you're paying for them. So yeah, I mean, look, I think that use case is the ROI on that is like almost, it's just a no-brainer.
yeah, and you said the same
Uh
thing. So it's moving. Everyone thinks of kinetics all the time because the drones are considered kinetics. But when you're looking at, I remember I was talking to a general in the Army, and I'm like, why are you interested in boats? And he looked at me and he says, the Army buys more boats than the Navy. We have to
yep,
move stuff. We have to move cargo. We have to move food. We have to move supplies. We have to move people. And if I can do it autonomously, that's a much cheaper, and I put people less in harm's way, right? And so
yeah,
so think about that. You're now in the water, or you want to do a cargo plane, and you need to move stuff, and you're in the water with no GPS. What do you do? And so this is the Delta Black engagement. We're doing early testing with them. It's the USV with Black Sea. We are designed into Havoc AI, which just announced a big round. We are designed into that, and those are public ones. And there's many others that we're engaged with that are not public. But all these are this. It's autonomous. When you get to the water or over water,
yep,
cameras don't help, right? And this is the real thing. You can't fly over clouds with cameras, right? You can't fly
right,
over sand or snow or featureless, things. And so,
absolutely,
but I think those use cases, per your statement, are very, I don't want to say practical, but economic. It makes a lot of sense if you
yep,
can have those boats or drones or things moving cargo, but they have to get to the right place.
yes.
How do they get there? Well, you need a navigation solution that's cost effective, because these are not just attritable, but they're designed for mass swarming of things, mass volume that are cost sensitive and power sensitive.
Yeah, amazing. And the productions increased and the shipments have begun, right, Mario? I mean, especially for your aerial INS, I believe it's quarter two of this year. You started production shipments. Where does that product roadmap? Where's that going for the rest of the year and throughout your portfolio?
So today we have a land vehicle. We call it the ground INS. This is that we're shipping today into the industrial market, and we're starting to look at SOCOM type opportunities and US UGVs, right, unmanned ground vessels.
Mm-hmm.
We have the X3, which is shipping into drones.
Yep.
And then we have the maritime product and the aerial. And these are the simple units. The maritime is ramping. That was announced last year, but that's, as you said, Black Sea is a public announcement. Others, a perfect example, we have a request, I can't say from who, but let's just say the Navy called us. We have this thing called the Strait of Hormuz. If everyone's hearing about this, you've heard this news, but turns out they're doing minesweeping and there's no GPS. It's all being jammed. So
absolutely.
The minesweepers are going out there, but
out there. Yeah.
They tag the mines, but they don't know where they're at because there's no GPS. So
oh my God.
We got an urgent request. We've accelerated some production to ship our technology out there for minesweeping, right? This is you feel like you're actually doing something. And then on the aerial unit, while we announced it at CES, the orders are coming in. And so all these, like I said, we're ramping. The nice thing is we designed, sometimes you get lucky, or you can say we designed it from the beginning, but we designed the technology on a platform where this is the core. And then there's 3 of them here, they're using everywhere. So we're ramping SiFog production. We're putting in additional capacity here. We've leaned ahead, and that's part of the funding round. And we're ordering additional capacity lines. We have a potential 1 or 2 big orders coming that we're trying to get up for. And this is all about just scaling, right? And this next 6 or 9 months, I tell the team, you ever watch the movie Rudy?
Yes.
Okay.
It's been a while, but yes.
Okay. So for the users, I tell this story to my team, right? I've been saying this for a while. Maybe the users will appreciate. Remember when he's in the tunnel and the captain grabs his helmet and he says, "Are you ready? Are you ready for this?" And Rudy says, "I've been waiting for this all my life."
Yes.
And I've been telling the team, "Are you guys ready?" Right? Because the orders are coming. Are you guys ready? Because it's about scaling now. And if you're not ready, you should go, because this is what it's all about. We've been working all this time to bring this technology to the market. And now the time is here where we're going to ramp production. And so I have a big Rudy poster. If you ever come out visit, it's in when I do the open forums. I have a big Rudy poster up there and I just point to it all the time. And,
I love that.
So
right? I love that. Well, and it's so important, honestly. I mean, at Exponential, actually, the Department of War DIB guy, right? The Defense Industry Base, undersecretary was up there. Basically, that's what he said. He's like, you can bring us something, but if you can't scale it, don't bother, basically. I mean, I'm paraphrasing very liberally, but yes, I mean, we're talking mass production at this point, and I think it's a real issue for a lot of other companies, Mario. So I love that you're in this place now where at this time you are ready to deliver. So, speaking of quantities and volumes and swarms, I think that's a great description of every booth I've ever seen you put up at any show. I couldn't even talk to you at Exponential because there's just so many people around you. I was like, hey, Mario, like, hey, Don. So for those that didn't have, your attention there or somewhere else, like for the autonomy community that's listening right now, operators, developers, program managers, what do you want them to understand about where GPS denied navigation is heading and where you're heading?
So first of all, I feel a lot of times, even I barely had time to walk around.
Oh yeah,
right. It was kind of nonstop, and then I think people come by and want to talk to you. So where we're headed, look, I think we should, at a high level, we summarize: GPS denied and jamming and spoofing is real. It's only going to get worse. I think people need to think up front. And my time I spent on Capitol Hill yesterday, and I go there once a month now. I was asked to come back in another 2 weeks at the Pentagon. I think there are requirements coming, right? The Department of War is not going to be buying stuff that does not have GPS denied capability. Exactly. So you need to design that up front. It can't be like, design what's your GPS denied solution? Or we have GPS. Well, that doesn't work, right? So you need to be thinking about having GPS denied capability from the beginning. Secondly, is we have this technology. We're able to scale. So, happy to work with customers. Go to our website, ANELLOPhotonics.com. There's an info. I think there's a link there where you can send in a request. We follow up very quickly. But we have technology that works. It's easy interfacing, right? We've designed this thing. It's standard interfaces: Ethernet, CAN, RS-232, RS-422. So we made it easy to plug and play. We can, if you're serious. We talk to customers, as I said, every platform is different. A boat is bouncing around different. Where you put it on the boat, but once we're designed in and it's in the same spot, we never have to touch it again.
There
So
you go.
we'll work with customers. I want to hear, what is your problem, right? What are you trying to solve? What is your platform? And our lead times are starting to grow. Our demand is through the roof, and so get in, talk to us early. We're always looking. And what are the new problems, right? What are the new use cases? Because we do have a roadmap. I mean, I don't like to talk too much, but I've learned out here in Silicon Valley, you have to disrupt yourself. So we will continue to shrink our devices. We work on the next generation already as part of this funding to do a little bit of R&D. But we are ramping production. We are scalable. We can deliver. The technology has been vetted. It's out in the field, both industrial and defense. It's in combat areas. So it's been tested under real jamming and spoofing, and it works really well. And the last piece is, I've spent, I'm not a military person. Thank you for your service, Don, but I've met so many people now, right? From special forces and military, Army, Marines. And, there's a piece here that this technology, and I truly believe that, ANELLO is a huge advantage for the warfighter. And anything I can do or we can do to bring this technology to the warfighter faster, to give us a competitive advantage, to bring this to market in the industrial space, to bring this to places where people can add performance value, the commercial applications, right? So you're going to start seeing, if jamming and spoofing is happening in areas, FedEx doesn't work, Amazon doesn't work, the drivers can't navigate, they're using paper maps. And so to me, it's how do we accelerate that, but also have customers come to us and say, here's my use case. How do we integrate? How do we get it? And those are the kind of things that, to me, is sort of the exciting part of my job now, is to find customers that want to deploy the technology, and then we quickly see how it helps and benefits them.
Well, great stuff. And if you saw me writing a little note, I love that line. You got to disrupt yourself. And so what I would say to everybody out there is, if you're not disrupting yourself right now, if you're building something and you're looking to chase DoD dollars or DOW dollars, and like Mario said, you haven't planned, you haven't baked in GPS denied capability, that's not a good plan. As they say, the plans, don't always survive first contact with the enemy. I will tell you that one will not, for sure. So anyway, thank you, Mario, for everything you're doing. This was a great update. It's always a pleasure and a privilege to have you on the show, learn what you're doing. It's been so wonderful to watch you over the years and watch ANELLO grow and change. And, that roadmap is solid, and we look forward to continuing to watch everything you're doing out there. So thank you, everybody, for watching. Go to their website, check out ANELLO.com and
ANELLOphotonics.com.
ANELLO, say it again.
ANELLOphotonics.com.
ANELLOphotonics.com. That's the website. Check that out. And thank you all. That is a wrap for Defense Tech Month. Thank you, Volatus Aerospace, for sponsoring this entire month. And thank you again, Mario. Really appreciate you. Best in everything. And we will surely see you again. We'll be in touch.
Thanks for having me. Thanks for listeners. Thank you. Ciao.
All right. Out here, everybody.